Okay, I'm going to see if I can do this recording through Zoom. So you want to know about these kinds of questions. And they asked for a general solution. So some of them asked to find a solution between a certain range, 0 and 2 pi, but this one wanted a general solution for all of them. So for this one, I'm going to worry about where sine would be equal to -1/2. So that's there at 5 pi over 6 and over there at 11 pi over 6. But it wanted all solutions, right? So not just 5 pi over 6, but if I went all the way around and added, I guess, 2 pi, then you would also have 17 pi over 6. And you could even go around one more time and have 29 pi over 6. So you could keep doing this infinitely, right? So this is like plus 2 pi, plus 4 pi. You could do again for 6 pi, and so on. So instead of doing it infinitely, I just say theta is 5 pi, theta over 2 equals 5 pi over 6 plus 2k pi. This would be all of them, right? This would be k equals 1. This one's k equals 2, k equals 3, and so on, so on. Then at this point, I wanted to get rid of the 2. I have theta over 2. I wanted theta. So I'm going to multiply that side by 2 and that side by 2. And I'm going to get theta equals 5 pi over 3 plus 4k pi. But I also had this one. So I multiply both sides by 2. And these are my 2 answers. Okay, which I think is, oops. All right. Now for this one, it's going to be very similar, except the period for tangent and cotangent isn't 2 pi like it is for everything else, sine, cosine, secant, cosecant. The period is pi. So if the cotangent's √3, I guess that means the xy coordinate we're looking for is √3 over 2, 1/2. So that's going to be here at pi over 6. The period's pi, so I don't have to include this one as well. I think I saw that it did on the solutions, but it's not really necessary because you see when you add pi, you get this one. So it all kind of works together. So for cotangent, all I actually have to do is say 5 theta equals pi over 6 plus k pi instead of 2k pi. That's because my period is pi, where in the period on this one is 2 pi. So I added 2k pi, but now I just add k pi. And then so I don't have to worry about that one. And I just divide everything by 5. And on that side, I think of it as times 1/5. But then I get theta is pi over 30 plus k pi over 5. So when I looked at, where did that go? Shoot. You look at what they did. Yeah, they did add in this extra one, but you see, you didn't really need to, because the yeah, they shouldn't have. You should have added k pi, not 2k pi on the cotangent one. But on the cosine, you would add 2k pi. You see, pi over 2 plus 2k pi, 3 pi over 2 plus 2k pi. Same way on the sine, but you don't have to do that on tangent or cotangent because of the period. Okay, and you also had another question. Oh, yeah, sure. Cosine squared minus 1 equals sine. So what I'm going to use here is that see, I can't solve these things unless I have all sines or all cosines. So when you have a cosine and a sine, you know you're going to have to do some identity to change it. And I'm going to change this cosine squared into sine squared. And then I'm just going to substitute that right in here. And now I've done it. I've turned it all into sines. So now it's just a matter of, let me see, let's, the ones just cancel right off. And I have negative sine squared theta equals sine theta. So what I want to do is I want to think of this as if I was solving this equation. I would say x squared plus x is equal to 0. Then I would factor out the x, and I'd say x is 0 or negative 1. I'm going to do the same thing here with it being sine squared. Oh, sine instead of x. Then I'll factor out my sine. The same way I did over here. So then you have that sine theta is 0 or sine theta is negative 1. So when sine theta is 0, that's there and there. I don't include 2 pi because it told me not to. And then sine theta is negative 1 right there. So that's 3 pi over 2. And there it goes. So hopefully that helped. I do have office hours, and if you ever want to just do it through like a video chat, I can send you a link if you'd rather do it that way. But I don't know. We'll see if how well this recording works. Sorry for the delay.